So you can put them aside, and we can go ahead and match up these. Now, if you could, please make yours match mine so that we're at least putting them in the same order. Because true or false, you could have switched circumcenter and orthocenter. True or false? Yeah, true. You could have switched circumcenter and orthocenter because both of those have a point of concurrency that can be inside or outside of the triangle, and that's the only one that's listed. Your in-center is written for you, so there's no choice for that one. And your centroid, that's the only one that's created by, that's the only one that's created by the medians. All right, so when we're talking about where do these things happen, if you're confident, you can start gluing. When we start talking about our circumcenter, the circumcenter can also be in or out of the triangle. Now, as far as the in-center and the centroid, those are always going to be inside of the triangle. So we don't have to worry about whether we have an acute, right, or obtuse triangle, because our angle bisectors and our medians are always inside of the triangle. Our circumcenter and our orthocenter are the ones that it's kind of dependent, who we're not really sure, depending on what kind of triangle. So it's real important that you think about that right triangle, because our perpendicular bisectors, our circumcenter is on that midpoint of that hypotenuse, and our orthocenter is at that right angle. Matching up which ones are created by makes sure that you have the right understanding of the right segment. What is an angle bisector? Hey, we're not creative when we name things in mathematics at all. We're not creative. If it cuts an angle in half, we're going to call it an angle bisector. If it cuts a segment in half at a perpendicular angle, we're going to call it a perpendicular bisector. Altitude is the height. So these special features of the triangles are what we're going to be quizzing and testing you on. That orthocenter is the point of concurrency. Our altitudes are the height of the triangle. That's kind of the boring one. That's the one that we don't necessarily think about. When we talk about our in-center, the fact that it's equidistant from the sides. And if you want to remember, it's created from the angles. So that angle bisector creates a situation where it's equidistant to the sides. The perpendicular bisectors for the sides are going to be equidistant to each vertice. That centroid, our pink triangle, that's the one that we kind of like the best. He's kind of fun. That point of concurrency is 2/3 of the distance to the vertex. And it also counts as that balancing point. Now, if you have your triangles from when we had our lesson in folding, if it helps you to go ahead and remember, this was our blue triangle when we talked about our in-center, when we folded and made our angle bisectors. This was our green triangle when we folded and made our perpendicular bisectors. This was our pink triangle when we folded and created our medians. And this was our purple triangle when we folded and created our altitudes. So having those triangles hopefully helped you see how everything was created, whether it's created from the midpoint. Does it go from the midpoint to the opposite vertex? Does it go from the midpoint at a right angle? Does it go from a vertex to the opposite side at a right angle? Does it slice the angle in half? Everybody sound okay with these? All right. Once you're finished gluing, go ahead and check out the back. So the back of this is a pretty interesting conversation about an equilateral triangle and recognizing all 4 points of concurrency. So give me a minute and think about each of those circumcenter, incenter, centroid, and orthocenter, and think about why they're all the same point in an equilateral triangle. Take a minute, discuss with your group, put some thoughts down, go. Able to work with kids. So this Genre Sketchpad program allows me to create and construct things electronically, and it has this dynamic feature where I can go ahead and change things. So I want to explain what a couple things are. The red is my original triangle. Each of these blue lines is a perpendicular bisector. The green lines are the radii of the circle, showing you that it's equidistant to each of the vertices. And what I can do is I can drag one of my triangle edges and I can change what kind of triangle I have. So if I have a perpendicular bisector, check out what happens when I have an isosceles triangle. So I'm going to go ahead and try to make this as true as I can to being isosceles. What do you notice happens? The blue, the blue is the perpendicular bisector. The green is my distance. This circle around is the circle that's circumscribed. This point of concurrency here is my circumcenter. So that's what it looks like when I have an isosceles triangle. How do I know that's a right triangle? Yeah, check out, there's my point of concurrency at the midpoint of my hypotenuse. Do you see it? How do I know this is an obtuse triangle? Look at the red triangle. How do I know it's obtuse? The point of concurrency is outside the triangle. So here I have an acute triangle. Here I have a right triangle, and here I have an obtuse triangle, and watch that point of concurrency change. I have an isosceles triangle at this point. Pretty cool, right? Okay, here is my angle bisectors. The red triangle is the one you're watching. The blue lines are my angle bisectors. The green lines are my distance to the sides of the triangle. And see how that circle is inside now? That's my incenter. No matter what I do, whether I have an obtuse triangle, whether I have an acute triangle, that incenter is always where? Inside. So let's go ahead and make it isosceles. Let's see if I can play with it. And I know it's going to be isosceles when, Watch that line at the bottom. Watch the green and the blue. See it? Now it's isosceles. All right, let's talk about the centroid. Centroids are created by what?
Bisectors.
Medians. And the medians bisect the segment, right? So it's the midpoint to the vertex. Midpoint to the vertex is our medians, right? So here I have an interesting story here. I've named a couple points. I've named the distance from F to B. I've named the distance from B to C. And I've named the distance from F to C. This plus this is always equal to that. Got it? What other relationship is true?
BC is like half of FB. No.
Yes. BC is half of FB. I'll buy that. Give me another relationship that's true. BC is half of FB, 100%. Another one, Maggie? FB is 2/3 of FC. If you are, send one person from your group to get a calculator on your market set like a bunny rabbit. Go, quick, 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 quick. Get a calculator, get a calculator. Quick like a bunny rabbit. If you don't believe me, what I would like you to do right now is take the distance from F to C, whatever distance I have here, and I'll try to make it pretty. Let's make this, how close can I get? Oh, take FC. Everybody, what are you going to type in? 20. Do this to me. Times 2 divided by 3. Go. 20 times 2 divided by 3. Here's FC. It's 20. What? FC is your median. FB is 2/3 of that distance. Would you please take that value that you have for FB? Don't do anything to it. Do you see it? Do you have it written out? Hit divide by 2. Just hit the divide. And do you see how it transfers the answer back down?
Oh my God.
What? Let's do it again. Pass the calculator. Pass the calculator to the left. To the left. And you press clear. You press clear. And here is a new FC length. Let's see if I can get it. Oh.
Wow.
You don't even have to do the calculator for this one, do you?
No, not really.
If the distance from F to C is 24, 24 times 2 divided by 3. Distance from F to B. Our medians are created from the midpoint to the angle opposite. They intersect at a point of concurrency. What is the name of that point of concurrency?
What is the centroid?
Yeah, because the media is the
Middle of the central.
center of attention.
Yes.
Media is the center of attention. The medians give you the centroid. All right, ready for our last one?
Yeah.
Here's an orthocenter. The altitudes intersect at a point of concurrency. If I have an acute triangle, I don't want to drag this vertex. If I have an acute triangle, there we go. It went back to being. If I have an acute triangle, the altitudes intersect inside of the circle. How do I know that's a right triangle?
Because of the
They intersect at the right angle.
Here, because if it's an altitude, that means that that's my right angle.
Oh.
Right? That means that that's my right angle. So here is when it's acute. See how it's inside? It's a cute little triangle. We'll move it over here. See if I can get this point back.
And this type of triangle, there will always be a right angle.
in any kind of triangle, any triangle can be acute, right, or obtuse. Now it's acute. If I go up here, the minute that point of concurrency, do you see this point of concurrency right here?
Yes.
The minute that point of concurrency lands on the vertex, I know that's a right triangle because this is an altitude and that's an altitude, so that's a right angle. What's going to happen, and I'll bring my whole, what's going to happen once my triangle is obtuse? See my point of concurrency? It's outside of the triangle. My altitudes are outside the triangle.
So if it's acute, it'll go.
If it's acute, it's inside.
If it's right, it'll be.
If it's right, it's on. If it's obtuse, it's outside.
Okay.
All right, here they are all together. Ready? Here's my perpendicular bisectors, and their point of concurrency is the circumcenter. Now, what I want you to notice that I did here is I cut the tails off. Do you see what I mean by cut the tails off? Meaning, I know this perpendicular bisector comes down here. I know this one comes down here, and I know this one goes up here. But once it hits that point of concurrency, I cut the tails off. Are you okay with that?
Mm-hmm.
Here's my angle bisectors. I didn't cut those tails off. Here's my medians. I cut those tails off. Here's my altitudes. I didn't cut those tails off. Now, watch. Pay attention to my angle measures. What kind of triangle is that?
Acute.
Keep going. Yeah, I'm going for isosceles, right? I'm a little bit off. Ready? What am I going for?
Obtuse?
No, right.
No. Sorry,
Right.
guys.
What kind of triangle is that?
Right triangle. Oh, wow.
What's going to happen next? Who knows what I'm going for?
Obtuse? No. Yes.
What's your question on your worksheet about?
An equilateral triangle.
Let's see if I can figure out how to get it equilateral. So isosceles, they all line up. But I have to try to get it to be a 60-degree. Am I getting closer? So try to figure out how to get this to be 60. We could wait all day. So if I can get this one, which is BAC. So BAC needs to be smaller. Let me put that one at 60 first. Ready? So if I get BAC at 60, that's this one, BAC, right?
Yes.
So now I need to get ACB at 60.
Oh, wait.
I'm getting closer, right? So this one needs to come down. That's pretty close. What is happening?
They're all lining up in the middle.
That's as close as I think I'm going to get. When it's an equilateral triangle, all of three or all four of those points of concurrency are exactly the same. Take a look at your triangle. if every single one of those things is true, that equilateral triangle is exactly divided into congruent triangles. That is exactly divided into congruent triangles. Let's go back and look at our sheet of paper. Take a highlighter or a pen of another color and recognize that this point of concurrency is going to give me this is the same as this is the same as this, right? Isn't that going to give me all of these equilateral or all these congruent triangles?
Yes.
Aren't all of these angles bisected?
Yeah.
Aren't all of these segments bisected at the midpoint? So all of these things are true. I have my altitudes, I have my medians, I have my perpendicular bisectors, and because all the triangles are true, I have all my angle bisectors. So I am creating all of these congruent triangles. Do you see these right triangles here? I have 1, 2, 3, 4, 5, 6 of them. How cool is that? All right, so what we want you to do is we want you to remember that the circumcenter is the point of concurrencies for our perpendicular bisectors. And in a obtuse triangle, it's outside of the triangle. So what I want you to do is right now, give me a rough sketch. Estimate where your midpoints are. And then if you need to use another piece of paper to estimate what a right angle would look like, go ahead and estimate where those perpendicular bisectors would intersect. Sketch it and see if you wind up with, now I'm a little bit off here, obviously, a point of concurrency. If you can get them all meeting at one point, then that means that you did a good job estimating your midpoint. I wonder which one I'm so far off of.
Don't we have to connect each midpoint?
Yeah, this one. They should be, no, connecting the midpoints gives you mid-segments. We want perpendicular bisectors.
So go straight up from each midpoint.
Yeah, so this one should be over here. Estimate your midpoints. And then use your straight edge. And this point of concurrency is the circumcenter, which is the point of concurrency for an obtuse triangle, and it's outside of the triangle. When we start talking about your altitudes, get your straight edge and draw your altitude. But then spin your paper around and think about the fact that your altitude for this side is going to be outside of the triangle. When I talk about its distance straight down, this is my altitude here. So from this vertex down, it's outside of the triangle. From this vertex down, it's outside of the triangle. And when I talk about this vertex, I have to extend and look at a perpendicular line. And I can see that those perpendicular lines are actually going to intersect way outside of the triangle. Now I was a little bit off because these are supposed to intersect. So check out how far off I am and think about how amazing it was that all of our times that we were, think about how all of our times that we were folding, it all worked out. So anytime you sketch, you run the risk of it not being accurate. But when we folded, we didn't have any of those problems. What's on your mind, Olivia? So because every time I sketch it, it doesn't work out, I'm reminded how amazing it is that when we fold it, it does work out. So think about that for a minute. All right, next activity. With your, don't start cutting it, turn your paper over, and I want you to look at the back of this. And we're going to talk about that whole idea about the medians and the centroid. How amazing it is that that centroid works out the way that it does. On the back of this, we have this conversation about Archimedes was interested in finding the balancing point, and that's what we did with our medians and when we found our centroid. Archimedes is famous for having these mobiles. Notice the one that's been floating around at the back of the room. So that one that's been floating around at the back of the room was done by one of the art classes. And they actually had, I talked to the art teacher and I'm like, can I have this hanging in my room as an example? Because the students had to create it so that it had this balance point. The size and the weight of this lightning and this cloud had to be the same as this cloud in order to keep the airplane balanced. So the way that this mobile works depends on that exact balance. That balance point that we found in the middle of our triangles with the centroid created by the medians created that same kind of balancing. And it was interesting when I talked to the art teacher about how they did it. She said the conversation always starts at the bottom. So the student who made that did not start with the sun. The student that made that started with the lightning bolt. So they made the lightning bolt first, the little cloud second, the medium cloud third, and so on up. With your group mates, go ahead. What do you think has to balance this 5?
A 5?
Another 5. What do you think has to balance those 5s? A 10. If this is a 6, what are these two? Is this a 6?
A 12?
It's got to be a 12. With your group mates, do the bottom one, and your mark it, set, go. So can you tell today's activity day? So for your next activity, you have on the flip side of this sheet a purple template of all the vocabulary from this part of the unit. And what I would like you to do is I'd like you to take one of these and go ahead and cut them up into 15 little tickets, and with your group match up to which ticket best matches which answer. Your mark, get set, go. You can glue your answers in when you're confident, but if you want to double check with mine, you can go ahead and do that. Sometimes we have to look at other things to know what it is we're talking about. This one has to be the distance from a point to a line because it's measured with a perpendicular line segment. We'll go over the rest of these after lunch and then we'll hand out your tests. So your mark is set, go.